today's lesson, guys, is kind of a really good lesson. It reviews pretty much everything we've done in the last 2 weeks. There's absolutely nothing new in the entire lesson, okay? We're going to talk about all the different types of HAs, VAs, limit statements, factoring, holes, vertical asymptote, everything, okay? So it's such a good lesson to tie everything together, okay? Then tomorrow is a work day. Don't forget, tomorrow is a work day. A work day is your day to work on pre-calc work. Any of the homeworks, you can watch videos, ask for help. I'm available to you for anything. You can work on the quiz that's due at midnight tomorrow night. So just think about what you want to use the time for. If you're going to work on the quiz, bring your laptop, of course. And I can't help you with the quiz, but I could maybe point you in the direction of your notes of where to look and stuff like that. Yeah, I think that's everything. Oh, and there's a homework check. I'll wait towards the end of class to do it. Just know that today's homework would be excluded from the homework check. Whenever I have a homework check, I would never include the day before's as an option, okay? Never, ever, ever. I give you time. But yesterday's could be, okay? All right, so let's get started. First example is write an equivalent representation of this polynomial. Notice it's a polynomial. It's not a rational function. Notice the difference, right? It's not a fraction. It's just a poly. And equivalent representation means factored form. So we're going to factor it, and then we're just going to sketch a graph. So remember, the first step of all factoring is to factor out a GCF. Okay? And then if you can do anything else, sometimes you can, sometimes you can't, we would continue. So in this case, and guys, from here on out, I'm kind of doing the factoring a little bit faster. You're not going to see me make a chart and talk about it a whole lot, because at this point, I'm telling you guys how to factor. Grab a candy as you walk by. If anybody is still having a problem with factoring, go back to the first module on Canvas, and there's a video that says factoring review. It's still there from the second day of school or whatever, okay? So you can always go back and watch it. So this would be 5 and 3. The 5 would be negative, 3 would be positive, okay? So that is the equivalent form of this polynomial. That's all that means, factored. Now to sketch it, we need the zeros. So if you set each of these equal to 0 and solve, we would get 0, 5, negative 3, right? Those are our zeros. 0, 5. It's a sketch, rough. You don't have to label it. And I want to remind you guys that these are all a multiplicity of 1. There's only 1 0, 1 5, 1 negative 3. Because these all have a multiplicity of 1, which is odd, they will cross. Okay? Remember, if it's a even number, like 2 5s or 2 3s or 2 zeros or something, that's when you bounce. All right? The only other thing we need to graph a polynomial, a sketch of a polynomial, is the end behavior. End behavior, we look at the first term. Hello. Abby, if you want to grab a candy that's my thank you for yesterday. And jump in with us. So this is our first term. Remember how we do this. When the degree is odd, that means our end behavior is going to go in the opposite direction. Thank you from yesterday. Opposite, and it's positive in front, so it's going to be like a line with a positive slope. It would be down and up, right? So a positive x to the first power would look like this. So the end behavior on our graph will do the same thing. This is a sketch. We don't care where we turn around, so that doesn't really matter. We start down, we cross, turn wherever you want to turn, cross, turn wherever you want to turn, and cross, and there's my end behavior going like that. Okay? So that's everything is a review. Absolutely no new material in anything we're doing today. All right? So each example is going to be like, wait, that's a blast from the past, or didn't we do that yesterday? Every single one. Okay, example 2. We're going to write it in factored form, and then whole and VA. So I'm going to just rewrite this down here. My numerator is the difference of 2 squares, x plus 4, x minus 4. And then again, that chart problem, and just so you know, I'm always looking for a GCF. as my first step. They sneak up on us. Okay, whole at 4. And we know, and it only asked for the x values of a whole in the vertical asymptote, but just as a reminder, there is a point of the whole, right? A lot of times we just need the x value, but if we needed the y value, we would take that 4 and plug it into these x's, okay? We don't need to do that. And then vertical asymptote is whatever's left in the denominator, right? So that's what we've been doing the last couple days. I'm going to give you some new vocab here because it comes up in your homework. Wholes are sometimes called points. That should make sense, right? Because it's a point of, and here's a fun SAT word, discontinuity. A point, order pair, where makes the graph discontinuous, right? We have to kind of jump over it. A point of discontinuity. Vertical asymptotes are sometimes called infinite, I'll go over why, discontinuity. Discontinuity. That one doesn't matter in this class. Good thing. Infinite, because a line is infinite, right? So it goes on forever up and down at -7, infinite up, infinite down, to cause a problem in our graph left to right, okay? Because one of the homeworks is which one of these, or it's something about the limit statement for an infinite discontinuity, a VA, okay? So vertical asymptotes are infinite discontinuity. Wholes are points of discontinuity. Point, infinite, okay? Stop me if anybody has a question. All right, let's tear this polynomial apart. First thing we're going to do is factor it. And jump in with us. Okay, so I'm going to rewrite this in its equivalent form. Remember, we just talked about equivalent form just means factored form. So again, I told you I'm going to go pretty fast through the factoring at this point. You want to grab candy? Pick something. And then in the denominator, it would be -6 and 1, so that's 3 and 2. Okay, so factoring pretty fast now. All right, that's part A. Part B, find any zeros. Wait, they're going out of order for my brain. So remember, we're thinking, you don't have to write this, or you can. These are the x values. My denominator can't be. I need to simplify. Okay, now I can answer all the questions, right? You have to simplify it to know. Okay, so 0 is anything left in the numerator, right? Do we have a whole? Yep, wherever we canceled, we're a whole. So x equals -3. And we're going to sketch a graph. So I am going to go ahead and find the y value of my whole. And to do that, I'm plugging in to the simplified version of my rational function, right? After I canceled, that's where I'm plugging in. So that would be -3 plus 4 on top and -3 minus 2 on the bottom. I would get -1/5. You can leave it as -1/5, totally fine. Or you could change it to a decimal in your calculator by dividing. 1 divided by -5 is -0.2. You choose which way you want to write it. It doesn't matter, okay? Vertical asymptote, yep. Right, x equals 2. HA, we're going to review HAs a lot today. HAs come from the degree of your numerator and the degree of your denominator. The last few days, we haven't had to do a ton of factoring. The curriculum, the book, whatever you want to call this, has been giving us a lot of the rational functions already in factored form. So some of you guys were confused about how do I find the HA? Well, remember, when it was in factored form, you had to multiply the first terms of your numerator and denominator, so it would be x times x is x squared, x times x is x squared. But one good thing about them giving us the rational function in standard form is that we don't have to worry about that. So I would go look at this one just a little bit easier. So the degree of my numerator is 2, the degree of my denominator is 2. Whenever they're the same, that's when you make a fraction, a ratio, out of the leading coefficients. So 1 over 1 would be 1. Okay? And we're going to review all the different types in an example in a second. Told you, lots and lots of review. Now we have to sketch the graph and do the domain. The domain is so much easier if you already have the graph, in my opinion. So we're going to sketch this graph together. Sketch, sketch, sketch means it's not perfect, and then we'll go back and do the domain. As I've been telling you guys, you will never have to graph a rational function on a test for me or on the AP exam. You don't actually have to physically graph. You have to be able to dissect it and know all of this stuff, and maybe multiple choice, choose the right graph that matches it. So I don't want you to stress too much about this. You should be able to put your asymptotes on there. Okay, so we have a vertical asymptote at x equals 2. We have a horizontal asymptote at y equals 1. We have a 0, that's an x-intercept, at negative 4. And we have a hole at negative 3, negative 0.2. Where is that? Who cares? Do the best you can. You'll make an open circle there. This is showing me that I have a branch in this little quadrant, because there's points here. And when you just sketch your graph, your branch, this green part, like arms, reach out towards the asymptotes. Okay? Now, where is the other branch? Is it here or here? Back in Algebra 2, you would have had to make a table of values and pick numbers over here to determine is the other branch up here or down here. Don't worry about that. I think the only types I've been giving you are like the ones that are in opposite quadrants. This is not as important. If you can identify all of the stuff, if you could like look at a graph and see, okay, those asymptotes and hole matches this, you'll be fine. Okay? But now that we have the graph, it's going to be so much easier to do the domain. Okay? So remember, we start all the way to the left, which is negative infinity. And then we're moving along, and the x value of this hole is that discontinuity, meaning I can't keep going. It's stopping me. I have to jump over it to keep going. So at negative 3, which was the x value of my hole, not included. And remember we talked about like doing this yesterday? When you do that, it's like a jumping over the negative 3. And we keep going until what? What's the next x value that's going to cause a problem for me? Nope. 2. Yesterday. Okay, so yeah, this vertical asymptote prevents me from going any further. So I've got to jump over the 2, and now we're on the other side of the 2 on this branch, and we're home free, right? So you should see your vertical asymptotes and holes jumped over. That's just my term. It's not like a real term, okay? Should be almost there, right? They're having a deep discussion about presidential stuff. Do you guys want to grab a candy? Jump back in with this. Okay. Any questions on that one? So if you missed anything, you take your time. It's okay. I want you to be happy with the decision. You're good? Okay. If you came in, you missed any of those, it was a lot of review, okay? But you can go back and look at that if you need to. You might be okay without it from an instruction. I don't know. All right. Example 4. Gummy bears, Skittles, or Sour Patch Kids. Sour Patch Kids are popular. Okay. I thought so. That's the one I bought 2 bags of. All right. So we are going to create an equation based on a graph. Whenever this happens, there's an endless number of solutions that could be correct. Your teacher, that's me, is always going to do the easiest one. Okay? But there's lots of different ways you can do this. I'll explain in a second. So rational function called f of x equals, there's my fraction. Let me pull some important stuff out of this graph, okay? In no particular order, it doesn't matter. I'm just going to identify some stuff. Like I see a VA at x equals 2. I see a hole at x equals 4. And we don't care about the y value for this. I see an HA of y equals 1. one more important piece. I missed it last period. What's one more important part of this? 0, right, Kaden? 0. And it is at, is that -3, I think? Yeah. Now let's build it. Let's build it. So it doesn't matter what you start with. Let's start with a vertical asymptote. That's what I wrote first. Before it was x equals 2, this is like the 0. It's not really a 0, but you know, set it equal to 0 and solve. It was a factor, so bring that 2 back to the other side. And since it's a VA, it should be left in the denominator. So the simplest version, which is what I like to do, is don't put anything up there. Could I put 4 up top and 5 on the bottom? Yeah, because 4 would cancel and leave 1 on the bottom. There's an endless number of ways we could show that there's a VA of x minus 2, as long as once you cancel, there's at least 1 left in the denominator, right? Okay, so that's good. We have a whole at x equals 4, so that's x minus 4. To be a whole, you had to cancel, right? Cancel makes you a whole. Again, could I have done 25 on top and 24 on the bottom? Wait, is that what I'm trying to say? Yeah. Or 25 and 25. There's an endless number of exponents you could do on that. But as long as it cancels in the denominator, it's a whole. Okay? That's the easiest one. And then, of course, the 0 comes from the numerator. So that would be x plus 3. And our horizontal asymptote matches, okay? Because the degree on top is 2, degree on the bottom is 2, so 1 over 1 is y equals 1. There's the easiest version of it. Okay? Good? Moving on. Next page. I know, I skipped a lot. How do you guys feel about polynomial long division? I kind of went really fast through it last period, and I don't want to go too fast if you guys are not feeling good about it. Remember long division? I'm going to do one. Let's see how you do. Okay. So, skipping all the instructions, because I've already taught you how to do it. How is it applied? Okay, so look at example 6. We have g of x. Find the equations for, let's answer these questions. So the first thing is factored form. Okay, so I need to factor this. And I see that I can factor out an x in my numerator. Right, I could factor out an x. So I would have an x factored out, and then the rest of it is a chart problem. Two numbers that multiply to get -10, add to get 3 would be, so that's my numerator completely factored, and the denominator also chart. 15 and 8 would be 5 and 3. Okay, factored form, equivalent form. Okay, we know x can't be -5 or -3. We'll have a whole at -5, but it didn't ask for that. Okay, fine. But we did ask for a vertical asymptote. You're a vertical asymptote if you're left in the denominator. Just a side note, we would have 2 zeros, right? A 0 at 0 and a 0 at 2 if we were graphing this or something. Our last one. Okay, and jump in with this. Okay, horizontal asymptote, remember, it comes from the degree of our numerator is 3, and the degree of my denominator is 2. 3 is greater than 2. When that happens, we have no HA. Listen, if there's no HA, you have to then say, but is there a slant asymptote? And the way you tell is if you subtract those, you should get 1. And that means, yes, there's a slant asymptote. So 3 minus 2 is 1. 5 minus 4 is 1. 100 minus 99 is 1. So as long as the difference between them is 1, we have a slant asymptote. And that's, excuse me, that's when you need to do long division, okay? So, do I do long division with my original equation? You could, but that's pretty nasty looking. Instead, you can actually take your simplified version Remember, your simplified version of your rational function is from when you canceled stuff, whatever's left. And yes, a little extra work here. I'm going to have to distribute because it's in factored form. I want it to be in standard form. I'm going to do long division with this versus this. That's allowed. Okay? So I'm going to use this space up here. It's like a space I didn't use because, you know, I can't fit it there. So we have x plus 3 is our divisor, and x squared minus 2x. Now, we haven't seen this year. I know it's something you might have talked about in Algebra 2, but whenever one of the pieces of your dividend, is what it's called, is missing, you have to put a placeholder there. So it's x to the second, x to the first. We're missing a constant, so you put a 0 there for a placeholder. We haven't seen that in this class so far, so I wanted to pick that out. And remember how to start with the first terms. You're asking yourself, what times x gives you x squared? And that would be x, right? X times x. So remember, where you place it is important, lined up with the other x's. And what I'm going to do here is x times x plus 3. So whether you write it and show it or do it in your head, doesn't matter, but that's what I'm doing. X times x plus 3. So x times x is x squared, and x times 3 is positive 3x. Are we writing this down, everybody? Okay, next step is subtraction. Don't forget, that means you change both signs, right? We're subtracting the whole thing. So if you're positive, you become negative. If you're negative, you become positive. These were both positive, so they became negative. That should cancel. We get negative 5x. Bring down the 0. Start over. What times this x, always that one, gives us negative 5x? Negative 5. So now I'm doing negative 5 times x plus 3, negative 5 times x plus 3. And really, you don't have to finish this. Because if you remember, what happens next, change both signs. Whatever's left, it looks like it's 15. That's your remainder, but we don't even need it. All you care about is the slope-intercept form of the graph, of the equation. You throw away the remainder. So your slant asymptote, sorry about that, your slant asymptote is just y equals x minus 5. It should always be a line, slope-intercept form. Okay. Do we feel okay about long division? I gave you one in your homework. The very last problem is because we need to know how to do it. So again, that's one of those things that if you're struggling with it, I'll happily help you with it tomorrow. You need to walk me through it. All right, we're almost done. Let's review HAs. I told you I'd give you a full review of horizontal asymptotes. So that's all we're going to do for these 4. HA. HAs come from the degree of our numerator, degree of our denominator, right? So in problem A, the numerator's degree is 1, which is less than the denominator's degree of 2. Do you guys remember what that HA is? This is pure memorization. I hear you somebody saying y equals 0. Yep. No matter what. If the top is less than the bottom, it's always y equals 0. It doesn't matter if it's a difference of any number. It could be 1 on the bottom and 1 on top and 100 on the bottom. As long as it's less on top, it's y equals 0. So think of how you can memorize that. You got to know it, right? In this one, degree on top is equal to the degree on the bottom. So whenever that happens, you have to look at the leading coefficients and you make a ratio, a fraction out of them. If that fraction can be simplified, of course you would, okay? I can't think of many situations that we would not simplify a fraction. The 5 halves is just 5 halves, okay? Here we have 2 over 1. 2 is greater than 1. What does that mean? No, there's none. If the numerator is greater than the denominator. Do we have a slant asymptote? Yes. We don't have to find it. We're just saying we know. If you wanted it, yes, we could do long division here. Okay. I'm not doing it, but I just want to show you something. If you were going to do long division, look, what goes in here starts with x to the second. It's missing its x term. That would mean a placeholder, okay? Not going to make us do it. If someone wanted to practice, this is the answer to it. So if you wanted to practice that one, that's that, okay? But it's just saying, yes, we know there is one because the difference of those two numbers is 1, okay? And then lastly, what is the degree of our numerator here? 0, right? There's no x. So that's 0 is less than 2. So, of course, whenever the numerator is less than the denominator, that's y equals 0. Okay, so there's a good review of our HA stuff. Our last one is all those limit statements we learned yesterday. Remember how we said there's like 3 different sets, and how do we tell the difference? Remember the snake, the ordered pair, all that stuff I said? Let's just review that, and then I'm done. Okay, so what I want you to notice is that there's a set. Let's just start with these two, that I'm going to underline in green. These two go together. Look, the limit of r of x as x approaches negative infinity, the limit of r of x as x approaches infinity. That's all the way down there, all the way down there. What does that make you think of? And behavior. Yes. Okay. Are you writing down stuff? Okay. Looks like it's like somewhere else. Not here. End behavior. These are end behavior. If x is going all the way left, that's the end. So what is this 2? Do we remember? In a rational function, our end behavior is affected by the horizontal asymptote. So we know this graph will have a horizontal asymptote at y equals 2. Here's the graph of it. Y equals 2. Look, as I go to the left, as I go to the right, I am blocked from going higher or lower by the 2. So that's that y value that's preventing me from going up or down. Okay? Look at the next 2. Approaching -3 from the left, approaching -3 from the right. What's happening is from the left, we're going down forever. From the right, we're going up forever. What does that make you think is in between those? What is that? Vertical asymptote, a vertical line. That's right. So this is your vertical asymptote. Think about the snake. It hits that -3 and it has to either go up the wall or whatever. Okay? So that means we would have a VA at x equals -3. And then lastly, these are where you see an ordered pair, right? As we approach 5 from the left and right, the y values are getting close to 3. You can see it. It's like 5, 3. That is a hole. Okay? So this is your hole. Okay? So being able to tell the difference. We're not going to graph it. We know 5 is undefined. Remember, undefined means it's in the denominator. Thank you very much, but we already knew that because we knew there was an x value of 5 for our whole, so that puts it in the denominator, right? Okay, so that's it. That's all. Okay? All right. Here is the homework. Remember, tomorrow is your work day. Bring what you need to work on. Laptop might be a good one. I need strength for the next period. We're graphing lines, making a table, and we're having a very hard time plugging x values into our equation.